Good morning, our respected sir. Myself Subhadeep Bhadra from Computer Science and Engineering Department, 3rd semester. Today I am going to deliver a presentation on the topic was logic gates. There was some contents are including in this topic. There was an introduction of the logic gates and the type of the logic gates, and then the symbol of the logic gates, and then the truth table of the logic gates, and at last the name of the logic gates like AND gate, OR gate, NOT gate, NAND gate, XOR gate, or exclusive OR gate, or NOR gate, or exclusive NOR gate, or XNOR gate. It's also called the exclusive NOR gate, or XOR gate, or XOR gate is also called the exclusive OR gate. And then at first we learn about the introduction of the logic gates. Logic gates are the fundamental building blocks in the digital circuits. They perform the logical operations such as AND, OR, NOT, etc. based on binary inputs. Combinations of these gates enable the creation of complex electronic circuits used in computers and other digital devices. And then we learn about the type of the logic gates, and there are the several types of the logic gates are including AND gates, and the AND gates is the outputs true if all the inputs are true, and then the OR gate, the output true if at least one input is true, and then the NOT gate, the output the opposite of the input, and then the NAND gate similar to AND but with inverted output, and then the NOR gate and similar to OR but with inverted output, and then the XOR gate or exclusive OR gate, outputs true if the number of the true input is odd, and then the XNOR gate or exclusive NOR gate, outputs true if the number of true inputs is even. And then this gets from the basis of the constructing more complex digital circuits. And then we learn about the symbols and truth table of the logic gates. And at first we are learn about the AND gate, AND gate symbols, and the AND gate truth tables. So that's why the AND gate symbols is the AND gate is the 2 input AND gate and the 3 input AND gates, and the Boolean expression is showing in these symbols. Y equals to is A into B, and this was the truth table, and the truth table was the input A and input B, and there's the output. Because of 2 inputs, so that's why the 2 inputs, so that's why the output is 0, and because of the 2 inputs are also 0. And this was showing there was a no signal are providing on the inputs, so that's why it is represented 0. And then it was signal is providing on the inputs, then it was represented by 1. So that's why the input A and input B were at first table are 0 0, then the output is also showing the 0. Then one input is 0 and the another input B is 1, then the also output is 0. And then the A input A is 0 and the another output input is 0, and then the output is also 0. And then the input is 1 and the input is another input is 0. It means the input A is 1 and the input B is 0, then the output is also 0. And then the input A is 1 and the output B and the input B is 1 and the output is also the 1. Is showing the input signal, and the 2 input signals are providing the input, and the output was showing the signals. And then we are talk about the OR gate, and this was the OR gate, and this was the OR gate symbols and the OR gate truth tables. So that's why the 2 inputs and the 1 outputs, and the 2 inputs are addition add, and this was the output. This was showing the symbols, and there was the truth table, and the truth table is there was a 2 input and the 1 output, and the input signal is going to the circuit, then it we are represent 1 and the input signals not going to the circuit, then it we are represent 0. So that's why the if the input is 1, then the input is 1 1, and then the output is also is showing the 1, and then the input is 0 0, then the output is also showing the 0 0. But one input we were providing the 0, that means the not signal are providing, and one input are providing the signal, that means the one input are providing a 1 input are providing a 1. So that's why a is 0 and the b is 1, huh? So that's why then the output is also showing the 1, and then the input a is 1, and then the input b is 0, and then the output is also showing the 1. It means the output also showing the result and this or the signals. And then we are going to the NOT gate. NOT gate is the one of the logic gates of the one input and the one output. It is the one of the gates. It has a one input and one output, and then the input are are providing us not signaled, then the output is showing 1, and the output is showing the signal is 0, then the input is showing 1. And then the NAND gate, and we are discussing the NAND gate, then the symbol and the truth table of the NAND gate, and the 2 input NAND gate and the 3 input NAND gate, and it is the combination of the 2 gates. And this is the AND gate and the NOT gate, and the AND gate is connecting to the NOT gate. So that's why the Boolean expression of the NAND gate is y equals to a into b bar equal a into b bar. So that's why the truth table is the a b 0, where 2 inputs are 0 but the output is showing 1, and then the one input is 0, it means the input a is 0, then the b is 1, then the output is showing 1, and then the one output is 1, it means the input a is 1 and the input b is 0, then the output y is 1, and then the two inputs are 1 1, and then the output is showing 0. That's why the AND gate was connecting to the NOT gate, and for this the AND gate was behaving this result and connect but because of it is connecting to the NOT gate, and that's why the result was reversed. It means opposite result are showing in this truth table. So that's why this is the truth table of the NAND gate. The two input are 0 0 and the output is 1, and then the input a is 0 and the b is 1 and the output is 1, and then the input a is 1 and the b is 0 and the output is 1, and then the input and two inputs are 1 and the output is 0. And then we are talking about the NOR gate. Okay, so NOR gate is the NOR gate is the combination of the two gates. It means the NOT gate or the OR gate is connected in this circuits. So that's why the Boolean expression is output is equals to a plus b bar, and then the input is 0 0 and the output is 1, and then the one input is 0 and the one input is 1. It means the input a is 0 and the input b is 1, and then the output is 0, and then the input a is 1 and the input b is 0 and the output is 0, and then the input a is 1 and the output a is 1 and the output input a is 1 and the input b is 1 and the output is 0. I am repeating to the truth table again. input A is 0 and the input B is 0, then the output is 1. And the input A is 0 and the input B is 1, the output is 0. And then the input A is 1 and the input B is 0 and the output is 0. And then the input A is 1 and the input B is 1 and the output is 0. This is the NOR gate. And let's we talk about the XOR gate or exclusive OR gate. This was the exclusive OR gate, and it was the truth table is two inputs and truth table is two input and one output, and that's why the two inputs A and B and the output is 0. The two inputs in and A and B are providing 0, and then the output is also showing the 0, and the two inputs are providing are 1 and the output is also showing the 0. But input A is we are providing 1, then the input B is providing 0, then the output is providing 1, and then the input A is providing 0 and the input B is providing 1, then the output is 1. So this was the truth chart of the XOR gate or exclusive OR gate. And then the exclusive NOR gate or the XNOR gate. And the XNOR gate is the truth table XNOR gate. This is the symbol of the XNOR gate or exclusive NOR gate, and the truth table of the exclusive NOR gate, or this was the two input and the one output. This was the two input are also 0, then it is showing the 1, and the two input are also 1, and then the output is showing the 1. Two cases the output is showing 1. There was a two inputs are 0 from one case, and from another case there was a two inputs are 1, and then both cases are output are showing is 1, but input is from case number 1 is 0, and the another case and the last case is the input are providing to the 1, but both cases our output are showing the 1. And then the input A is 1 and the input B is 0, then the output is 0, and then we are providing the input A is 0 and the B is 1 and the output is 0. And this is the what is the universal gate? Okay, so what is the universal gate? Universal gate is a which can implement any boolean function without need to use any other gate type. The NAND and NOR gate are universal gate in parentheses. This is the advantages since NAND and NOR gates are economical and easier to fabricate and are the basic gates used in all IC digital logic families. Who invented the logic gates? George Bull, inventor of the idea of logic gates. He was born in England. There was a Lincoln. He was born in the Lincoln, and this city was in the England, and he was the son of the shoemaker in a low class family. Who is the father of logic? Aristotle. The father of logic is the greatest Greek philosophers. Then this is the original logic gates look. This is the logic gates actual look like where it works in real life, and this is the IC. What is the logic gates in binary? A logic gate in fancy term simply means a device that can take one or more binary inputs and produce a single binary outputs. Logic gates can be implemented in a few different ways, but we are going to focus on ones implemented with transistor. Why 0 and 1 are used in logic gates? In the logic gates, 0 and 1 are used to represent the two possible states of a binary system. This binary system aligns with the on and off states of electronic switches from the basic of digital computing. What is the half adder? Half adder, it is a combinational logic circuit. You can design it by connecting one AND gate and the one XOR gate or exclusive OR gate. A half adder circuit consists of two inputs terminal, namely A and B. Both of these add two input digit 1 bit numbers and generates the output in the form of a carry and a sum. What is a full adder? A full adder is a digital circuit that performs the addition. Full adders are the implemented with logic gates in hardware. A full adder adds three 1-bit binary numbers, two operands and a carry bit. The adder outputs two numbers, a sum and a carry bits. What is a full subtractor? A full subtractor is a combinational circuit that performs the subtractor involving 3 bits, namely a minute and b the subtracted and 3 and bin, and the bin means the borrow in. Okay, so first is the minute and the second is the subtracted in and the third is the be in, it means the borrow in. And then the it three inputs, a minute and b subtracted hint and the b in it means the borrow bit, and it produces two outputs, d means the difference and the bout it means the borrow out. So this is the full subtractor. And what is the half subtractor? And then the half subtractor is the subtractor is a combinational circuit. It is the combinational circuit which is used to perform the subtraction of two bits, and it has two inputs, a minute and b subtracted and two outputs, difference and borrows. It means when two binary numbers are subtracted, then you are using the half subtractor. It has two input and it is generating the two outputs such as borrow and difference. It was two inputs, so that's why the four conditions are available, because of 2 to the power is equals to 4. So that's why there was some picture are showing a full adder circuit and half adder circuit and the full subtractor circuit and the half subtractor circuit. And thank you.